Okay, so what I would like for you to do is to just have out a sheet of paper and follow along with me and write down the things that I'm going to tell you about a polynomial flowchart. Okay, so if you look right here at the top, I just need for you to write the title, which is Factoring Polynomials Flowchart. Underneath it, or to the left, far left, you're going to kind of write out the steps. Okay, so we all know that the first step that we are always going to do whenever we look at any polynomial is to factor out a GCF. So that's step one. So if you had something like 5x squared plus 10x minus 15, before you did anything else to look at any other step, you're going to take out that GCF. So for this particular one, the GCF would be 5, and you're going to just divide everything by the GCF, which is there, and then put what is left inside. Now, from here, you could go on to the next step of dose, T-chart, and bottoms up. But we're just going to stop right there because the first step you always do is take out the GCF. Now, once you have done that, you're going to look at the polynomial type. And so what that means, so that's the next little thing that you do. So you draw this and factor out GCF, polynomial type. Okay. The next thing you're going to do is you are going to look at it and say, okay, is what I have a binomial, which means 2 terms, a trinomial, which is 3 terms, or a polynomial with 4 terms? So once you've done that, then you're going to look and say, which one is this? Well, for this particular one, this is 3 terms, so it's a trinomial. So you would then go to this section on the trinomial chart. Now, I'm going to move back this a little bit more so that you can see it. Okay, let's just look at this part. Okay, so is it a binomial? And if it is a binomial, okay, you're going to do these particular things. So what you're looking at is this binomial, but actually these are perfect cubes, and we have not done that, so you don't even need to write that. What I want you to know is if you factor out the GCF and then you see that it's 2 terms, then you have to decide, is it a DOS or not? Okay? And remember, for it to be a DOS, it has to be these things, which are 2 terms, both are perfect squares, and subtraction. Now, once you have figured that out, such as this one right here, which is x squared minus 16, then you can set it up with x minus 4, x plus 4. Now, let's pretend that it's 2 terms. They're both perfect squares, but instead of it being subtraction, it's addition. You cannot break those down anymore, so it does not factor. So that's why it's called prime. So again, we are not doing this particular little section here because that's sum of cubes. Some of you could look over it and figure it out and do some stuff with it, but it's not necessary for this particular test. Okay, so let's pretend like you look at it and now you say, okay, self, there is a trinomial here. What am I going to do? Well, when there is a trinomial, you have two options, which is the a or the x squared, remember the x squared, is it 1? And if it is 1, then you see, okay, self, what multiplies to the last number and adds to the middle? So here is our example. So what multiplies to a negative 24 and adds to a negative 5? And those two factors are negative 8 and 3. So all you have to do is break those up and put those factors like so. Now, if it is the other way, which is where the x is greater than 1, your method is going to be a little bit different because that's where you're going to be using bottoms up. Okay, so let's just pretend that now you have an equation that is larger than 1 in the x squared or in the a position. So what you're going to do from that is very similar to this, but at the very end, you're going to do, what we call bottoms up once you're going to divide by the coefficient. So let's pretend like you had this particular problem. Okay, let's pretend like you had 2n squared plus 5n plus 2. So, first of all, I know that it's a polynomial. There's no GCF. It's not a difference of squares. And my n squared is greater than or is not 1. So this means that x squared is 1. And this means that x squared is 2, 4. It could be anything. Okay? So, I do similar to what I did before, but now what I'm going to say is, what is 2 times 2? Well, 2 times 2 is 4, and it has to add to my b, which is 5. So what is 2 times 2 that equals 5? 2 times 2, that doesn't work, 1 and 4. So now you take your first term and you say n plus 1, n plus 4. The only thing that is different from this to the one where x is 1 is now you are going to divide by your coefficient. You have to use this number. So can this be reduced? Well, it can't be reduced, but what you can do is do bottoms up. So then you have 2n plus 1. Now this one can be reduced. So now I have n plus 2. So my final answer here is 2n plus 1 and 2n plus 2. So that is the trinomial and the binomial. Now you're going to look at just one more area, and that is if it is 4 terms. So what do you do if you look at something that has 4 terms? So here's what you're going to do. If you had a problem that was 5x squared, whoa, sorry about that. I need to change it. 5x squared plus 10x plus 7x plus 14. Okay, so this is the grouping and taking out the GCF and doing all that. So in order to group it, because there's 4, the rest of them are 2 or 3, you're going to put parentheses around the first one and the second one. All right, now what's the GCF here of just this one? The GCF is 5x. Then what are you left with? X plus 2. Okay, what is the GCF here? 7. And what are you left with? X plus 2. So you take this, which is now your GCF, it's in both of them, and you have x plus 2 as one of your, binomials. Then you look at what is left in this, okay? And what's left is going to be your second term, which is 5x plus 7. So then now you have factored that using grouping as well. So very quickly, let me kind of go over the flow chart with you one more time so that you can kind of understand it. The first thing you're going to do is take out a GCF. That's your, your very first step. Then you're going to see what kind of polynomial type is it. Is it 2 terms, 3, or 4? If it's 2, you're going to go over here and see if it's a difference of squares. If it is, you factor it. If it is not, it's prime. Then you look over here and see, is it a trinomial? If the a or the x squared is 1, you do a t-chart for what multiplies to c and adds to b. If it is greater than 1, then you see what multiplies to a times c and adds to b. Then you have to do the bottoms up method with the coefficient. And then finally, if there are 4 terms, then you factor it by grouping. So I hope this helps, and I hope you were able to take good notes.